Hi, I hope everyone's doing good. Today we're going to go over some higher level Pythagorean theorem problems with SOHCAHTOA in it. So this page should be review. It might be written differently than you remember. You might remember a squared plus b squared equals c squared. That's great, but I want to make sure you understand that the legs are the two sides that touch the 90 degree, and it doesn't matter. That's why I don't call them a and b. It doesn't matter which is which. Leg squared plus the other leg squared has to equal the hypotenuse squared. The hypotenuse one is the slanted one, or the one across from the 90 degree. And you'll notice I put parentheses around my formula. We're going to start doing Pythagorean theorem with some negative numbers, which you don't do as much in lower courses, but we do it a lot in pre-calculus. So I want to make sure you guys get used to using those parentheses when you use Pythagorean theorem. Then down below, we're reviewing SOHCAHTOA. Stands for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent theta is opposite over adjacent. Remember, it depends on where theta is. If you draw an arrow all the way across the triangle from where theta is, that's the opposite leg. If you find your hypotenuse, just like in Pythagorean theorem, the slanted one across from the 90, that's the hypotenuse, which means the other one must be adjacent. It's the leg that touches theta. It's adjacent to, right next to theta. So everything depends on where theta is. If I move theta in that picture, all these labels are going to change, except for hypotenuse. Okay, so here's what we're looking at. If I give you a point 3,2, we are always going to make it a triangle by connecting it to the origin, which is a fancy name for 0, 0, and connecting it to the x-axis. It will always make a triangle. It will always make a right triangle when we do that. Then we're going to use the fact that that went through the point 3,2 to label the sides. So 3 on the x, this must be 3, and 2 on the y, this must be 2. So the first thing we're going to do is use Pythagorean theorem to solve for this missing side x. So Pythagorean theorem, it doesn't matter which one goes first. Leg squared plus the other leg squared has to equal hypotenuse squared. 9 plus 4, 13. Square root both sides. We won't have a calculator. We will leave it as the square root of 13. This side is root 13. Now that we have all our sides, we're going to fill in SOHCAHTOA. I want to mention real quick, because it's going to change on the next slide, the hypotenuse is always a positive number. So that hypotenuse, when I got the square root of 13, it's positive square root 13. I'm going to talk about it more on the next slide. So now we have our triangle. I didn't mention it yet, but when we put theta in these triangle problems, theta always goes between the x-axis and the hypotenuse. So this angle is theta. So you could label your triangle OAH. I like to draw an arrow. That's O. Hypotenuse is the slanted one, H, which leaves adjacent for the one that's left over. See if you can answer SOHCAHTOA now. So sine is opposite. I just labeled the 2 as O. Over hypotenuse, we just found that as root 13. Your pre-calculus teachers, which means this year your integrated 3 teachers, are not going to require you to rationalize that. If you don't even know what I'm talking about, that's fine, because we are going to leave that answer as the answer to sine theta, just like that. Cosine theta, A over H, 3 over root 13. Tangent theta, O over A, 2 over 3. This is what we're looking for in these problems. This is a pretty basic one. Things are going to change on the next slide. Okay, here we go. Big difference. I put this in quadrant 2, which means one of the measurements is negative. I mean, you can see it right there, negative 4, 2. Make it a triangle, connect it to the origin, 0, 0. Connect it to the x-axis, always the x-axis. Makes a right triangle. Puts theta between the x-axis and the hypotenuse. Label your sides, but this time, since it's negative 4, I'm going to label this side negative 4. And then positive 2 is up 2. We need to find the missing side. So using our parentheses, leg squared, doesn't matter which one you do first, plus the other leg squared equals, I should have labeled that x squared. Remember, when you square a negative number, it is always positive. You will only ever have positive numbers coming out of Pythagorean theorem. 4 squared plus 2 squared equals x squared. x squared equals 20, x equals root 20. We do not need to do anything else with that. We will just write equals root 20 where the x is. And now we will work on our SOHCAHTOA. Based on where theta is, O, draw an arrow all the way over there. O, hypotenuse is the one we just found. A. See if you can answer the SOHCAHTOAs. Find sine theta, cosine theta, tangent theta. Pause your video. Sine, opposite over hypotenuse, 2 over root 20. No need to rationalize, that is the answer. Cosine, adjacent, negative 4 over root 20. Make sure you include that negative, that's why it's there. And then tangent, opposite over adjacent, 2 over negative 4. You do need to reduce that. If you can reduce the whole numbers, we expect you to. So negative 1/2. You should know that it doesn't matter where I put the negative sign. Notice on the first one, which wasn't fully simplified, the negative's on the bottom because it was on the negative 4 originally. But then in my answer, I just kind of put it in front. It can go anywhere in front of the fraction. Top, the very front, or the bottom. But you need one negative sign in your final answer. Okay, next problem. Notice I got rid of the graph paper. These numbers aren't whole numbers, so graph paper isn't going to do me any good. So, same idea. Connect my point to the origin. It's kind of missing, but you get the idea. And then to the x-axis. Always connect it to the x-axis. It will always make a right triangle with the x-axis. And that will put theta between the x-axis and your hypotenuse. Label the sides based on the numbers given. So negative 2 root 3, so negative 2 root 3, and negative 3. We are looking for the third side. Take a minute and set up your Pythagorean theorem to find the hypotenuse of this triangle. Okay, here it is all set up. This is where the parentheses get real important. So, negative 2 root 3. First of all, remember the negative's going to go away, so it will be positive. You will never have a negative result when you're squaring numbers inside Pythagorean theorem. When you square that, I'm going to walk you through it slowly the first time. You square everything. So, negative 2 squared is 4 times. When you square root of 3, you just get 3. So that means that becomes 4 times 3, which is 12. Plus negative 3 squared is 9 equals x squared. X squared equals the square root of 21. Oops. X squared equals 21. X equals square root of 21. So a little bit harder with that 2 root 3 in there. Now see if you can do your SOHCAHTOA. I'll label the triangle with you if you'd like. Opposite, hypotenuse, adjacent. See if you can answer sine, cosine, tangent. Okay, notice I have a box around sine theta because that is the final answer, negative 3 over root 21. But cosine is not done yet. Just like earlier when we had 2 over 4, we reduced it. If you have a root over another root and they can reduce, we expect you to reduce them. So negative 2 does not change. Imagine they don't have roots. 3 goes into 21 7 times. So root 3 goes into root 21. Divide, you have root 7 left. This is the answer we're looking for. You divide, simplify roots, just like you simplify fractions. Then on my tangent, 2 negatives is not proper form. 3 over 2 root 3, right? The negatives cross out. This is my final answer. So a couple things happening here. In orange, squaring a 2 root 3. We need to be able to do that pretty quickly and easily next year. And then reducing our fractions when it's possible. Let's try another one. Connect the point to the origin and the x-axis, making a right triangle. Theta is between the x-axis and your hypotenuse. Label the sides based on the coordinates given. Positive 3 on the x, negative 2 on the y. See if you can find your hypotenuse. See if you can finish this problem. Pause your video and see how far you can get. Okay, Pythagorean theorem should have given you root 13 for the hypotenuse. Sine, negative 2 over root 13. Cosine, 3 over root 13. And tangent, negative 2 over 3. Notice when there's a negative involved in your picture, Some of your sine, some of your trig functions come out to be negative and some of them don't. We're going to talk more about that in pre-calculus, but just being able to find the missing side and then find your trig ratios just looking at your picture is what we want you to be able to do today. Okay, changing it up. Notice the picture's already drawn for you, and we gave you two of the sides, but they're not the same sides. It's not the legs like I've been giving you in the past, right? If you know the coordinate, you know the legs. If I draw the picture, I can give you any two sides I want. But still the same thing happening. Theta is between the hypotenuse and the x-axis. We still connected some point to the origin and then to the x-axis to make this triangle. We are still going to use Pythagorean theorem to find the missing side, but we have a different side given, so our equation is going to look a little different. Leg squared, x squared, plus leg squared, 3 squared, equals hypotenuse squared, 6 squared. Make sure you always put the hypotenuse on the equal to side of your equation, on the correct side of your equation. You never add the hypotenuse to another side. Carefully do your math. So it should show -9. So now we have to do a little bit of subtracting to get x squared. And then square root both sides, x equals root 27. The answer to Pythagorean theorem will always come out to be a positive number. You need to look at what direction you went on the axis to get to your point. So this point, this number, x, is right here on my picture. I'm going to write it in. But based on what we know about the xy plane, right? This is the x-axis, this is the y-axis. These numbers going this direction are positive, right? This would be +1, +2, +3, etc. But the ones going this direction are negative. So my root 27 needs a negative in front of it. That one little tiny negative makes the biggest difference ever once you get to pre-calculus. So look at your axes and figure out if it should be positive, negative. Let's talk about the y-axis while I'm here. These ones going up, those are positive, right? 1, 2, 3. If it was down, those would be negative. So if you ever go downwards, you have to make your value negative. Pythagorean theorem will always give you a positive. You have to check and see if it should be negative. One of the biggest little mistakes people make all through pre-calculus. Okay, now figure out your SOHCAHTOA. You've got theta. Label your opposite adjacent hypotenuse. And see if you can answer the sine, cosine, tangent questions. Pause your video. Check your answers with mine. The sine theta reduced, 3/6 reduces, and we expect you to reduce those. And then again, notice my cosine and my tangent. On cosine, I put the negative on top because it's technically root 27, that is the negative, but it doesn't matter if your negative's on the top or on the bottom, like I wrote for tangent, or just in the very, very front. Just make sure you have a negative, one negative sign for cosine, and one negative sign for the tangent solutions. Let's try another one. Given the picture, everything else, theta is still between the x-axis and the hypotenuse. See how far you can get on Pythagorean theorem for this problem. What would the missing side, which we will call x, be for this problem? Pause your video. Okay, hopefully you got square root of 84. I will write that in my picture, but then I will remember that that is supposed to represent a measurement on the xy plane, and because that measurement is going down from the y-axis, I should write it as negative root 84. You have to check your axes. Left is negative and down is negative. See if you can answer the 3 questions on the side. Pause your video. Okay, check your answers with mine. Hopefully you reduced the cosine solution and you crossed out the 2 negatives on the tangent solution. Here's another one. Why don't you see how far you can get on your own? Start by trying to find that missing side. Pause your video. Okay, did you get root 21 when you finished your Pythagorean theorem? But Pythagorean theorem does not include negatives. This problem was going down from the x-axis. My solution represents a number going down, so it needs to be negative root 21. SOHCAHTOA, negative root 21 over 5, 2 over 5, and negative root 21 over 2. None of them reduce this time. They don't always reduce. Hopefully you remembered that negative sign. One more. See if you can do this problem all on your own. Pause your video. Okay, Pythagorean theorem gives you root 33. Because this measurement, the purple root 33, is up from the x-axis, and the y-axis is positive when you go up from the x-axis, it actually stays positive root 33 in this problem. Then fill in your sine, cosine, tangent, and check and see if you got the same thing as me. So remembering to check if it should be positive or negative is so important. You're going to hear me say it. If you're lucky enough to have me next year for pre-calculus, you're going to hear me talk about it all the time. So hopefully you guys are getting a better grip on that, and I hope you do well.